Okay, we are going to have some more of the fundamental ideas here. Some of them I don't actually use all that much as I move up into higher levels of algebra, but there's a couple things in this section that I think are critical. So let's get started and I'll take you through it. First, I've just got some ideas here about what is the multiple of a number. Well, the multiple is basically the multiplication table for each number. So if I've got 2, all the possibilities are 2 times 1, 2 times 2, 2 times 3, right on down the line. Those are all the multiples of 2. And we have multiples of 3. We're just going to take 3 and we're going to go through the multiplication table. Those are multiples. If it is divisible by a number, then it divides in evenly. So if I have 8 is divisible by 2 because it divides in evenly and gets us 4. Now, divisibility tests, I don't need these all the time, but they really are helpful. But the most important one is you've got to remember if it's an even number, it's divisible by 2. This is the one I use all the time. The next thing I'll always check is it divisible by 5? And you know it is divisible by 5 if it ends in a 5 or 0. Okay? You know it's divisible by 10 if it ends in a 0. So those are the ones we use the most. And I can really find myself getting away with this on nearly all of them. Now another useful one, if none of those work, you're checking out 3 generally to see if something is divisible by 3. And what you check there is to see if you could add up the digits. Are those digits, do they make a number that's divisible by 3? So I've got 1 plus 2 plus 3, that's 6. Well, that's divisible by 3, so 123 must have been. And let's check. If I divide 3 into 12, I get 4. 4 times 3 is 12. I've got nothing left. Bring down the 3. 3 goes into 3 one time. So by adding up all the individual digits, if the new number that you create is divisible by 3, then it is. And then lastly, there's others, but the only other easy one that we'll look at here is for 6, was it divisible by 2 and 3? If it was, it's then divisible by 6. Now we'll look at some of these and talk through them. So 5,625, is that divisible by 2? Well, no, the final digit's a 5, so it is not. Now divisible by 3, let's add up all the digits, we get 18. Is that divisible by 3? Yeah, it is. So we're divisible by 3. How about by 5? Yeah, the last digit was a 5 or 0, so yes. Now 6, we needed to be divisible by both 2 and 3, but it wasn't. We were divisible by 3, but not 2, so it's not divisible by 6. And then lastly, divisible by 10, we already saw it isn't. It would have to have ended in a 0. Okay, so let's try some of these. Divisible by 2. Well, yeah, the last number is an even number, so yes, it's divisible by 2. Now to check 3, we're going to add up all the digits. So I get 13, 19, 21. Now 21 is divisible by 3, so yes, this big number 4,962 must be divisible by 3 as well. So I'm going to put a little box around it. Okay, 5, no, it doesn't end in a 5 or 0. 6, was that, oh, hold on, we said this one was true too, so let's put a box. Now 6 is true if it was true divisible by 2 and 3, so yeah, it was. So it's also divisible by 6. 10, no, we got to end in 0, so no. Okay, we'll try another one here. We are not divisible by 2 because we end in a 5. Now let's check divisible by 3. Well, we're going to add up the digits. So I get 10, 16, I get 21 again, which we already know is divisible by 3, so that works. Divisible by 5, yeah, because we end in a 5 or a 0. Divisible by 6, no, we needed 2 and 3, so that's not going to work. And 10, no, because it ends at a 5. Okay, now this is where prime factorization in particular, this is an idea. I think most of algebra rests on the idea of understanding factors. It is the most crucial idea to getting how all of this madness works. And so what we want to find are the factors of a number. We want to say factors are two numbers that multiply together to create that number. Now there are some numbers like 7 that are prime. There's only 1 and 7 that can multiply together to create it. But most numbers are composite numbers, meaning they are made up of two numbers multiplied together. Well, the factors are those individual numbers. So 72 is actually made up of 8 times 9. Now, we can go even further than that, though, because 8 and 9 are made up of individual numbers. So what we're going to do is learn how to break something down into its smallest pieces. And then when they're multiplied together, they're called factors. Super important for algebra. Okay, so I already talked about this. A prime number is one that all you can do is multiply it by 1 in itself, nothing else. Composite numbers, there's other numbers that factor together to create it. Now there's just a bunch of examples here, but so notice there's lots of them. So the primes, only 1 and 2 create 2, only 1 and 3 create 3. So it's good to be familiar with these basic ones, especially when we're factoring. Okay, now let's do the prime factorization of a number. So here's how we do it. I do this exactly like this. I've got this tree approach where I'm going to see 48 is divisible by 2. So I'm going to divide it by 2. And anytime there's an even number, I just keep dividing by 2 over and over again. So let's go to the end here. They have broken down all the numbers. So whenever you reach a prime, though, you're going to circle it. So 2 times 24, well, the 2 is done. It cannot break down any further, so I'm going to circle him. But 24 is not done. He's not prime yet. He can go further. And I make 4 and 6. Those two multiply to get 24. Now they're factors, but they're not prime yet. I could go farther. They're made up of numbers too. So I get down where 4 is made of 2 and 2. 6 is made of 2 and 3. Now I don't need the numbers along the path. I need only the factors that are primes. And so 48 is actually made up of these prime numbers. These are the smallest pieces that you can multiply together to create 48. But if you do, these are the same thing. 48 really is 2 times 2 times 2 times 2 times 3. They're the same thing. And that's 48 in its smallest factors, its smallest pieces. So we're going to try 80 here. Now if it's even, I just divide by 2. Now 2 is done, so I'm going to circle it, but I'm going to keep going here. 40 is made of 2 and 20. I circled the 2 because it's prime. Just going to keep on going. Okay, I've gotten all the way to the end. Now everything has been broken down to its smallest pieces. So the number 80 is really made up of 2 times 2 times 2 times 2 times 5. I have broken it into the smallest pieces that I can make, the prime factorization. Okay, we'll do it again with 60. Now you could do this another way, you'll get to the same place. But I just always do the evens. Okay, so 2 was done, 2 was done. Now 15, this has to be made up of 3 and 5. It's not even, so I tried 3. Okay, I've got my smallest pieces. So 60 is made up of 2 times 2, 60 is made up of 2 times 2 times 3 times 5. And I cannot underestimate how important, or overstate I should say, how important this idea is. We're going to use this a lot throughout this course. I use it even in higher level math. You've got to know how to break the numbers down into their pieces. Factoring is essential. Okay, nothing new here, just a more complicated one. They saw 12 and 21, but I would have broken this down by 2 because it was even. Get it down to its parts. Okay, I got 126 and I know it's even, so I'm just going to chop that thing in half. Okay, so what about 63? Well, if you weren't sure, you see it's divisible by 3 because we could add that up. 6 and 3 is 9. So we're going to divide this by 3 and get 21. This is divisible by 3 as well. Now I have broken it down into its smallest parts, and 126 is made up of 2 times 3 times 3 times 7. Let's try another one. Now I'd recommend you pause the video, try it yourself. I'm going to start. Okay, this is an even number, so I'm just going to cut it in half. Okay, am I right about that? Yeah, I think so. Okay, 197. I don't know if that is divisible. That would be strange if they gave us something. Oh, it's not that. It's that I did this wrong. Okay, sorry about that. Let's try again. 294 should have been 2 and 147. Okay, now that's divisible by 3 because it adds up to be 1112. So I can divide this by 3. Get 49. And that is made up of 7 and 7. All right, now these are the primes, so I'm all done. And 294 is made up of 2 times 3 times 7 times 7. Okay, now anytime we go through the multiplication table with the numbers, so I'm running 12 through all the possibilities. It's just the multiplication tables, and 18 has been run through the multiplication tables. Sometimes what you find is there's a point where they both run into the same numbers. They have common multiples. So all of them here are in red. Now, what we're often going to want to use when we're doing tricky things with fractions, lots of other reasons, we want to find the lowest, the least common multiple, the smallest number that they share, because if we find the smallest, it's going to make our work easier for us. So our least common multiple here is 36, the lowest one they both share. Now, you can do this by just multiplying out, like you just do the multiplication table and you find the smallest number they share. Well, it's 60. You can do this here, just start going through the table. Now we'll take 12 through. Now you can just work your way through there. You're going to get there. This method isn't the best. We're going to see a more clever way. But 36 is the first multiple that they share, the lowest one. So I'm just taking it through the multiplication tables. Am I right about that? No, I was right about that. Okay, now let's take 24 through. Okay, we're not done yet here. We've got, hold on, get to 72, so I guess I needed one more here, yeah. So I just ran through them, kept multiplying until I have my match. So 72 is the smallest number they both multiply into. Okay, now here's a better approach. Now that's true, but there is so much power in understanding when numbers are made up of other numbers. So we have now broken 18 and 12 up. So 12 is made of 2 times 2 times 3. 18 is made of 2 and 3 and 3. Okay, well here's the beauty of factors, one of many. But so if I want to find the least common multiple, I'm going to look at the numbers that they already share a 2. They already share a 3. So they both share a 2 and a 3. Now, watch what happens. If I just say, okay, well they share a 2, they share a 3, and then I bring down any other pieces that they didn't share. So they shared a 2, just bring down a 2. They shared a 3, bring down a 3. Well, they also had 2 and 3 on there. I'm just going to bring those down. Okay, now if you multiply that together, you get the smallest number that they can multiply into, which is 36. They shared a 2, shared a 3, also had a 2 and a 3. I'm going to bring those down as well. Now let me do some more of these here. So if I break 9 down into its pieces, I get 3 times 3. 12 is 2 and 6, 2 and 3. Okay, so I'm going to put these like this. Okay, so anything they share, I'm just going to bring it down one time. Then anything they don't share is going to get brought down individually. So they shared a single 3, but everything else I just bring down. Now let's just multiply this out. I've got 9, I've got 18, I've got 36. And if you tried the brute force method, you'd get to the same place. Okay. So I'm doing my tree here. All right, so 18 is made up of 2 times 3 times 3. 24 is made up of 2 times 2 times 2 times 3. Okay, anything they share gets once. Everything else is going to just come down. So I shared a 2, shared a 3. Anything they don't share comes down. So I just need to multiply this out. What I've got, let's do it here. What have I got? Oh, that's easy. 8 times 9, so we get 72. And if you had done the brute force approach, you'd get the same number. This is the smallest number that they can both become. And the way I find out is by sharing the factors get counted once, and everything else just comes down. Okay, so some more of the same. The numbers have been broken down. They shared a 2, I bring down 1. Shared another 2, bring down 1. Shared a 3. Now any other numbers they didn't share come down. Multiply it together. I get the least common multiple. Okay, do it again here. 3 and 7. So I'm just breaking down my numbers to the smallest pieces, the prime pieces. Okay, I'm just writing them so they line up properly here. Okay, so I broke them into my pieces. Well, they share the 7, and that's all they share. So 3 times the 1 7 that they share times 2 times 2. Just brought everything else down. So what do I get? 21 times 4, I get 84. Okay, let's try another one here. Just slicing down by the even numbers. Okay, so 24 and 32. Okay, so every time they share 1, I'm going to bring down 1. So they shared 3 2s. Now, everything else they don't share gets brought down individually. And I get this. What do I got? 4, 16, 32, get 96. Now, the brute strength method, just chug it out, would have worked too. But I think this is good because it also helps you understand the power of factors. Okay, so we learned a really important trick about how to find the prime factors. That's the most important thing. And then once we have them, we can use the power of that to find the least common multiple, the smallest number that they both multiply into.